9-4 is transforming quadratic functions. Quadratic functions are basically things that give you a parabola, so kind of that U shape or like the lowercase n shape. What we're looking at is if you change the equation, what happens to the graph is kind of essentially what we're doing. And want to look at different parts of that. So my Roman numeral 1 is changing A. And in case it doesn't come to your mind right away, I'll maybe kind of squeeze up above there. You could put it somewhere on your page. But our generic equation was y equals ax squared, so some number of x squared. It could just be like 1x squared or like a 5x squared. But then plus bx plus c. So this lowercase a is technically the x squared coefficient. It's the number in front of x squared. And what happens then is if you want to try to think about it logically, you could say, well, I wouldn't write this in green yet. We're focused. I wouldn't write this in green yet. If we have y equals x squared, if you pick some number for x, like maybe 3. 3 squared is 9, right? So if I have my a is going to be my number right there. If I multiply 9 by a big number, a number that's far from 0, it's going to make y quite a bit bigger than 9, right? Or if I multiply my 9, which was my 3 squared, by like a 1/2, something close to 0, then it makes it smaller. Y isn't as big. So as you change a, that's going to change how steep your parabola is because it's changing how big y is for a certain x value. So I'm going to try to write it this way. So this is kind of what I would write. But if you can kind of make sense of it logically, it's less like kind of just memorizing things. I'm going to say the closer a is to 0, so that'd be like the 1/2 that we had. The closer a is to 0. We said that made the y value smaller. So that's going to make the parabola not go up as steeply. It's going to be a wider parabola. So the wider the parabola. And in case that whole wider doesn't make a whole lot of sense, I'm just going to draw kind of like a really wide parabola, something like that. So that would maybe be like a y equals 0.1 times x squared or something like that. You could say the converse, kind of the opposite of that, the farther a is from 0. And this includes like both positive numbers and negative numbers. So the farther a is from 0. We said that makes the y value go up faster, so it's going to make for a narrower parabola. The narrower the parabola. And probably most people are picturing it something like that, kind of an upward one. But it could technically be a downward one as well. You could have a really skinny parabola that opens downward, something like that. The difference between opening up and down. People remember what makes it open up versus open down? Yep. Yeah. So this one here then is going to have anything that opens up is a positive a. And we had that in the notes earlier, but you could say like positive people, they smile a lot. Where if you have somebody who's really negative, they tend to frown. So a negative a, that'd be somebody who frowns a lot with a very large, disproportionately large mouth. But okay on those?
Just keep straight faces, we don't count.
So to try to apply this stuff, I want to say this. I'm going to give you 2 line equations. We have a y equals 3x squared and a separate equation, y equals negative 1/2. So this is kind of the application. How well do you know the stuff from up above? So y equals 3x squared and y equals negative 1/2 x squared. So if I were to have a graph of that, my y equals 3x squared, what can you tell me about y equals 3x squared?
It's going to be steeper than the other one.
It's going to be steeper than the other one, and it opens upward. Now, because it's just a 3x squared, there's no like plus bx in there, or a plus c. Its vertex is going to have to be at the origin. So I'm going to say maybe this here is my y equals 3x squared, and it should look symmetrical. Mine really doesn't. Maybe if I try it again. Something like that. Not necessarily better. But so that's that one. If I have my y equals 1/2 x squared, that's wider, we said. What else do we know about it?
It's down.
Down. Yeah. So y equals 1/2 x squared would be like wider and down. that. Technically, it should never get to be a straight line. It should always be getting steeper and steeper as it goes away from the origin. So try to fix that a little bit. As it gets further from the origin, it should get steeper and steeper. So maybe I label those. And you may see some questions that say something like, which equation has to fit the graph if given this? And you can look and say, okay, that one is positive, so it could only be opening upward. It's narrow, so it has to be this one, and so on. All right, we okay? Feel all right on A? So the next part then is Roman numeral 2, which is changing C. So C is that constant, the number that's not paired with an x. So it's the number at the end. So it'd be like y equals 3x squared plus 5x minus 7. So then minus 7 would be the C. So I'm going to say C is the y-intercept. Is the y-intercept. And that was in an earlier section of notes too. Pretty sure it was section 3 when we were looking at the story problems. Because if you take your equation, that original equation, if you put a 0 in for x, the ax squared is going to cancel out, the bx is going to cancel out, so the only thing left is the c. So c has to be the y-intercept. That's what you get when x is 0. For a story problem, you could say that's going to be the initial height. So when you get a question that says, the height of a baseball is given by this equation, c is always going to be that height when time is 0. And with that, it's possible if you were to have so maybe put an example, y equals, let's say 5x squared. So does my parabola open up or down? Up, because 5 is positive. Plus 6x still opens up because it just matters about the 5. Minus 7. What is c going to be in that one there? Negative 7. Yep. So the y-intercept is going to be a negative 7. So it crosses the y-axis down 7 from the origin. Feeling okay? All right. If I were to maybe try to give you another example, let's say we have y equals negative 16x squared. As soon as you see that minus 16x squared, you know it's going to be like the height of a thrown object. I don't think you necessarily need to know that, but plus 14x plus 5. So this is a thrown object that starts at a height of 5. Yep, so if you wanted to, you could label it, so initial height, or maybe starting height, if that makes more sense to you. Often they say initial in science and math. If you were to have this thing start 8 feet higher, so I'm going to say if starts 8 feet higher, so now you have somebody, maybe this is the height of a golf ball, that's hit. Now somebody's on some platform 8 feet up in the air hitting a golf ball off, which seems random, but it's been done, trust me. Okay, if you have y equals, is it still minus 16x squared? Yeah, changing the height's not going to necessarily impact that. We'll say it's like an identical hit. So then it would also be the 14x, but my last number has to be 13. Yep. Because if the initial height was 5, if you make it 8 feet higher, it's going to be 13 feet for an initial height. Oh, that's totally wrong. I didn't write it in. So then the new height has to be 13. I must have been saying 5 as I wrote it. You feel okay on C? Right. Then we'll do the very last thing, Roman numeral 3. And we'll say falling objects. I got a little bit ahead of myself in Roman numeral 2. I'm going to say A equals negative 16 when the initial height is in feet. If you ever have an equation for the height of an object, neglecting air resistance, that A value is either going to be negative 16 or negative 4.9. And what it is it's half of the acceleration due to gravity. Gravity accelerates, it speeds up things down towards the Earth at a certain rate. It's 32 feet per second squared. So something falling will speed up by 32 feet per second every second. And half of that is going to be the 16. The other option His acceleration due to gravity is 9.8. I wonder if you guys have learned that one yet. So half of that's 4.9. So A is going to be negative 4.9 when initial height is in meters. So if you say, I don't know, Zoe spikes a volleyball, here's the equation for the height of the volleyball, blah, 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 blah. That initial height's going to be what's the height when the hand hits it. You could have picked any of you volleyball players for that. So then, the last example, then we're done. Write an equation for the height of an object. So write an equation for the height of an object. Dropped from 30 feet. So say the questions at the beginning of class that were just trying to get me off track about where'd you go biking was because you're planning next Sunday. You're going to be waiting for me with a water balloon 30 feet up in a tree on the Muscatawa Trail. And so what time did you go? And you want to calculate how fast is this baby going to hit the ground because you want to make sure you get me because I'll pick on you in class the next day if you don't. All right. What do I do with my 30 feet? Goes in for C. So I'm maybe going to start by writing y equals ax squared plus bx plus c. So my 30 feet goes in for c, so it'll be a plus 30 there at the end. What does a have to be because it's 30 feet? Yep. So we have y, or you could say h for height, really, equals negative 16x squared. And because it's dropped, we don't have anything with this b. What they're really doing is they're trying to set you up for Algebra 2, where Algebra 2 you learn more what the whole equation is, but b is that initial velocity, how fast, if you were to throw the water balloon down, what's that initial downward velocity? Good. Gravity makes things fall, right? So gravity is taking away from something's height, or it's speeding it, it's slowing it down on its way up, or speeding it up on its way down. So the 16 has to be negative because it's trying to make the height of an object smaller, closer to 0. Great question. I love how you're thinking. So if you whip it down, if you were to take and throw something down, then it would be this b value. So if you were to change it to that, you throw it downward at 10 feet per second at me, then you'd have this minus 10x. I probably wouldn't put that in. It'll mess up the story problem for you. But this would be the height of an object that's thrown downward, down is the minus, at 10 feet per second from an initial height of 30 feet. But that's where that comes from, which is the physics part, which just makes me happy.